Imagine you had a job where hour after hour, day after day, you were to do nothing but compute multiplications. Boredom would quickly set in, leading to carelessness, leading to mistakes. Let us here look on all the calculating and computing devices. As the name suggests, computer is a device made for computation, includes arithmetical calculations as well as the logical operation. Therefore, for hundreds of years inventors have been searching for a way to mechanize manual tasks. Let us see the major milestones in the evolution of today's computer. Early computing machines. Abacus. The abacus, which emerged about 5,000 years ago in Asia, can be considered as the first computer. It was an early aid for mathematical computations. It was made up of wooden frame with several rods having beads. The frame was divided into two parts called earth and heaven. Each rod in heaven had 2 beads and earth had 5 beads. This device allows users to make computations using a system of sliding beads arranged on a rack and aids the memory of the person performing the calculation. Early merchants used the abacus to keep trading transactions, but as the use of paper and pencil spread, particularly in Europe, the abacus lost its importance. The abacus is still in use today, principally in the Far East. A skilled abacus operator can work on addition and subtraction problems at the speed of a person equipped with a hand calculator. However, multiplication and division were slower. Napier's bones. In 1617, an eccentric Scotsman named John Napier invented logarithms, which are a technology that allows multiplication to be performed via addition. The magic ingredient is the logarithm of each operand, which was originally obtained from a printed table. But Napier also invented an alternative to tables, where the logarithm values were carved on ivory sticks, which was named Napier's bones. Pascal's adding machine. In 1642, Blaise Pascal, the 18-year-old son of a French tax collector, invented a numerical wheel calculator to help his father with his duties. This brass rectangular box, also called a Pascaline, used 8 movable dials to add up to 8 digits. Pascal's device used a base of 10. For example, as one dial moved 10 notches, or one complete round, it moved the next dial, which represented the tens column, one place. When the tens dial moved one round, the dial representing the hundreds place moved one notch, and so on. Its drawback was its limitation to addition and subtraction only. Leibniz calculator. In 1694, a German mathematician and philosopher, Gottfried Wilhelm von Leibniz, improved the Pascaline by creating a machine that could also multiply. Like its predecessor, Leibniz's mechanical multiplier worked by a system of gears and dials. Jacquard's loom. In 1801, the Frenchman Joseph-Marie Jacquard invented a power loom that could base its weave upon a pattern automatically read from punched wooden cards held together in a long row by rope. In the Jacquard's loom, the presence or absence of each hole in the card physically allows a colored thread to pass or stop that thread. Difference engine by Charles Babbage. The real beginnings of computers as we know them today lay with an English mathematics professor, Charles Babbage. He is known as the father of the computer. Babbage noticed a natural harmony between machines and mathematics. Machines were best at performing tasks repeatedly without mistake, while mathematics, particularly the production of mathematic tables, often required the simple repetition of steps. In 1822, Babbage proposed a steam-driven calculating machine the size of a room, to perform differential equations called a difference engine. This machine would be able to compute tables of numbers such as logarithm tables and would have a stored program and could perform calculations and print the results automatically. Analytical engine. After working on the difference engine for 10 years, Babbage was suddenly inspired to begin work on the first general-purpose computer, which he called the analytical engine. This device, as large as a house and powered by 6 steam engines, would be more general-purpose in nature because it would be programmable, thanks to the punch card technology of Jacquard. But it was Babbage who made an important intellectual leap regarding the punched cards. Babbage saw that the pattern of holes could be used to represent an abstract idea, such as a problem statement or the raw data required for that problem solution. Furthermore, Babbage realized that punched paper could be employed as a storage mechanism holding computed numbers for future reference. Because of the connection to the Jacquard loom, Babbage called the two main parts of his analytical engine the store and the mill, as both terms are used in the weaving industry. The store was where numbers were held, and the mill was where they were woven into new results. In a modern computer, these same parts are called the memory unit and the central processing unit. Lady Augusta Ada, the first programmer. Babbage befriended Augusta Ada Byron, the daughter of the famous poet Lord Byron, who was fascinated by Babbage's ideas. She learned enough about the design of the analytical engine to begin fashioning programs for the still unbuilt machine. While Babbage refused to publish his knowledge for another 30 years, Ada wrote a series of notes wherein she detailed sequences of instructions she had prepared for the analytical engine. The analytical engine remained unbuilt because the British government refused to get involved with this, but Ada earned her spot in history as the first computer programmer. Ada invented the subroutine and was the first to recognize the importance of looping. In the 1980s, the U.S. Defense Department named a programming language Ada in her honor. Tabulating machine. Herman Hollerith. In 1889, an American inventor, Herman Hollerith, also applied the Jacquard loom concept to computing. His first task was to find a faster way to compute the U.S. Census. Hollerith used cards to store data information, which he fed into a machine that compiled the results mechanically. Each punch on a card represented one number, and the combinations of two punches represented one letter. As many as 80 variables could be stored on a single card. Census takers compiled their results in just 6 weeks with Hollerith's machine instead of 10 years. In addition to their speed, the punch cards served as a storage method for data, and they helped reduce computational errors. Hollerith brought his punch card reader into the business world, founding Tabulating Machine Company in 1896. Later to become International Business Machines, IBM in 1924, after a series of mergers. In the ensuing years, several engineers made other significant advances. EDVAC, John von Neumann. In the mid-1940s, John von Neumann joined the University of Pennsylvania team, initiating concepts in computer design that remained central to computer engineering for the next 40 years. Von Neumann designed the Electronic Discrete Variable Automatic Computer, or EDVAC, in 1945, with a memory to hold both a stored program as well as data. Mark I. Howard H. Aiken. Howard H. Aiken, a Harvard engineer working with IBM, succeeded in producing an all-electronic calculator by 1944. It was about half as long as a football field and contained about 500 miles of wiring. The Harvard IBM Automatic Sequence Controlled Computer, or Mark I for short, was an electronic relay computer. The machine was slow and inflexible, but it could perform basic arithmetic as well as more complex equations. ENIAC. Another computer development was the Electronic Numerical Integrator and Computer, or ENIAC. This was the first general-purpose electronic digital computer invented by John Mauchly and J. Presper Eckert in 1946. This is the story of the evolution of computers. After going through a long journey of the evolution process, the first electronic computer was invented. The development journey continues. EDVAC. In 1951, J. Presper Eckert and John Mauchly developed the Universal Automatic Computer, or UNIVAC. It is the first commercial electronic computer that could handle text and numeric data.